All right, guys. So page 21 of your packets. Oh, that means Guys, stop talking. Get your packet out. Come on. All right. So, couple of things before we get started. So, first off, your test for this unit is going to be Thursday. No, everything unit 8. So, I will give you guys a review tomorrow. We should hopefully finish up today, maybe do like a tiny little mini lesson tomorrow. But we should be pretty much done by today. Then when you don't forget your journals will be due the day of the test. I will allow you to use your journals on the test. All right. And then let's see. My brain for a second. So yeah, journals are due. Any non-Delta Math related assignments are due by midnight on test day. If you are making up Delta Maths Christmas break, you might as well get some work done, because remember, when we come back from break, we have a week and then exams. So that means the final Delta Maths, I will take those final grades the week, by the end of the week we get back from Christmas break. All right. So if you have Delta Maths that you still need to do, you need to get them done. All right. Besides that, I will say I was pretty happy with you guys on your unit circle quiz yesterday. I mean, I had some that were perfect, but some that were pretty close. At the very least, y'all are pretty decent, at least the degrees. So that's good. All right. The biggest issue I saw was honestly the points. A lot of you got the points too, are pretty close to it. You just really need to work on those radians. All right. So the radians, in my opinion, is probably the hardest, because it's just like, you just got to remember the numbers. All right. It's not like a repeating pattern. It's pretty much, you just got to memorize them. Okay. So today we are continuing to talk about sine and cosine functions, specifically how to graph them. So yesterday we talked about amplitude with the graphs. So can anyone tell me what the amplitude is? It's the last thing we did yesterday.
And I changed the wave.
It changed what part of the wave?
The top and the bottom.
It basically changed the max and min. So it either made it wider or it made it thinner or whatever. All right. Now, today we're going to talk about the rest of the key features with sine and cosine graphs. All right. So amplitude is typically controlled by the number being multiplied outside of the sine or cosine function. Next thing we're going to talk about is the vertical shifting, which is also the midline. All right. Now, some of y'all were struggling a little bit with the graphing of the amplitude yesterday. I'm going to teach you a new trick to graph amplitude, which I think personally is easier, but I couldn't have done it without teaching midline first. All right. So I'm on page 21. So any graph primarily comprised of either a sine or cosine function is known as sinusoidal. All right. So technically, both of these are considered sinusoidal functions. If you ever take Math 4, you will see sinusoidal regressions, which is basically matching a sine function to a set of points. Now, these graphs are stretched vertically by the amplitude, which is what we learned in the last lesson. And there are some other transformations as well. So today we're looking at y of a sine of x plus c and y of a cosine of x plus c. So remember, the a values give us our amplitude, and the c values is what's going to control our vertical shift dash give us the midline. Now, before we even get into it, we talked about vertical shifts before in previous units. Does anyone remember what a vertical shift actually does to a graph? Does it change the shape of the graph? No. But it does change its what? Not necessarily. It changes its position on the graph. All right, so basically it either moves higher or it moves lower vertically. So let's look at this graph. So we're going to consider the function f of x is equal to sine of x plus 3. All right, so they already gave us the sine of x graph. Oh my gosh. All right, so they gave us the function sine of x, which is the graph that's already graphed. Now, based off of this function up here, specifically this plus 3, how do you think this graph is going to be shifted? It's going to be up 3 units. So we are going to shift every main point on this graph. So that's here, here, here. Basically, all of the main points that we found yesterday. We're going to shift all of those points up 3 units. All right, so negative 2 pi will go from 0 to what? 3. Negative 3 pi over 2 will go from 1 to where? 4. Then 0 to 3 again. Negative pi over 2 will go from negative 1 to where? 2. Back to 0. And then it repeats. So 4, 3, 2, 4. Or 3, sorry. So your new graph will look something like this. So it's literally the exact same graph. It just got shifted up a couple units. All right, the shape didn't change, the amplitude didn't change, how high the wave didn't change. It's pretty much the exact same thing. Now, another thing I would like to note is, remember how I said that C value also gives us what is called the midline? Well, the midline is really, really important when we're graphing a trig function. So the midline is a horizontal line. So it's a horizontal line that goes through the middle of our sine graph. And we typically write it as y equals whatever our C value is. So in this case, my midline would be at y is equal to 3. So I'm going to actually draw my midline. I'm just going to do it as a dashed line going through y is equal to 3. Now, here's why the midline is so important. What is my amplitude? So what's my A value here? What's my A value? 1. So my A value would be right here. So there's an unspoken 1. So A is equal to 1. So my amplitude is equal to the absolute value of A. So that'll be the absolute value of 1. So that would be 1. Now, what we didn't talk about with amplitude yesterday is your amplitude, definition-wise, is actually the distance from the midline to the max dash min. So if my amplitude is 1, that means from the midline, my max is going to be 1 away from the midline. My min is going to be 1 away from the midline. So this right here is my amplitude. So that's my amplitude. So typically when I graph a sine and cosine graph, I always start by finding the midline and finding the max and the min through the amplitude, because then that gives me essentially my checkpoints. Because if you notice, this is my max, this is my midline, and this is my min. What's true about every point on this graph in terms of those lines that I just drew, those vertical, horizontal lines that I just drew? What's true about every point on that graph? They're hitting at least one of those lines. So it's literally checkpoints. And it's the same pattern. So if we go from left to right, it goes mid, max, mid, min, mid, max, mid, min, mid, and the pattern repeats. All right. So let's try that with this next one. Now, this is where our midline is going to help us a lot, because we don't have the parent function or our normal cosine graph. So we're going to base it off of this function. So first off, my A and C value, let's label those. What's my A value? 2. What's my C value? 1. So that means that my amplitude is equal to 2, and my midline is at what line? Y equals what? 1. So to get my max and my min, to get my max, I'm going to add 2 to 1. So I'm going to do 1 plus 2. So my max is at 3, or y equals 3. And for my min, I'm going to subtract 2 from 1. So 1 minus 2, so that's negative 1. All right. So I'm going to draw my midline. So that's y equals 1, so right here. And then I'm going to draw my max and min. So here's my midline. My max is going to be 1 away or 2 away from the midline. So 1, 2. So that's at 3. So right here. And then my min is going to be 2 away from the midline. So 1, 2. So right here. So all of my points will fall under, or will hit at least one of those lines. Actually, we'll hit only one of those lines each. They'll go in the same pattern. Now, let's think back to, and you don't have to look at this, just look at my screen. Let's think back to when we did the parent functions of a cosine function. I always based it off of, like I said, you always look at how it's starting at the y-axis. So your cosine function is that purple line, the sine function is the green line. So where does the cosine function start? Does it start at the max, the min, or the midline on the y-axis? It starts at the max. So guess what's going to do for our function? It's going to start at the max on the y-axis. So that means this cosine function on the y-axis, it's going to start right here on the max. Now, where did it go next? So what was typically the pattern? After you go one way, what was typically the pattern? Don't you just hit every other line on the way, going all the way down? All right, so where do you think I want to go next for pi over 2? Am I going to go max, mid, or min? Well, we're already at the max, but where am I going to go next? Mid, then min, then back to mid, then max. Now, on the other end, so I'm going backwards now. If I go backwards, where do I go next? Mid, then min, then mid, then min. And just like that, we have our cosine graph, and we didn't have to do any calculating. So knowing the general shape of your graph will help. So, a couple of things to note. A sine graph always at the y-axis always starts at the midline on the y-axis. A cosine graph, it depends on the a value. So if the a value is positive on the y-axis, it starts at the max. And if the a value is negative on the y-axis, it starts at the min. And then it follows the pattern. All right. Does that make sense to everyone? A little bit easier than yesterday? Just a little bit with the graphing aspect? All right, we'll do more practice. So get the equation of the horizontal line that the curve falls 2 units above. Sketch this line. All right, so basically they're just saying that our max, we already found this, it's at y equals 3. Our min is at y equals -1. So that being said, what's my range? What's my lowest y value? -1. What's my highest? +3. All right, let's try another one. So we got 2 different graphs. So we're going to graph both of them. So first off, we have 4 sine x of -2. So my amplitude will be what? Amplitude is 4 because it's our a value. My midline would be what? Y equals what? -2. It comes from my c value. So whatever's being added or subtracted on to the sine function. So remember, amplitude is how far away the peaks are from the midline. So my max would be 4 away from the midline. So where would my max be at? So in other words, would I add or subtract the 4 to -2? Add. So that would be at y equals what? 2. What about my min? So you do y equals -2 minus 4 because we're subtracting 4. So y is equal to -6. So I'm going to graph all 3 of my lines. I'm going to graph this, this, and this just so I have my reference lines. So my midline at -2. So that's my midline. Then I have my max at 2. So right here. And I have my min at -6. So right here. Now, remember, Sine functions, they are going to start where at the y-axis? Are they going to start at the midline, the max, or the min at the y-axis? The midline. So this is where it's going to start, on the y-axis. Now, is my a value negative? No. So am I going to go to my max next or to my min next if my a value is positive? Max. So you're going to go up next. So we're going to go up to my max at pi over 2. Then where do I go? Min. Not the min, but the mid. Then my min. Then what? My mid. Now, on the other side, if I go backwards, so I'm at my mid, so if I go backwards, I'm going to my what? Not backwards. Min. Then where? Mid. Then max. Then mid. So this is what my sine graph looks like. So this is 4 sine of x minus 2. Now, what's the range of that graph? So what's your lowest y value? -6. What's your highest? 2. So your range is from -6 to 2. So basically, whatever your max and min are, that's what your range is. All right, let's try the cosine one together. So first off, your amplitude would be what? Well, the amplitude's actually 2 because amplitude is the absolute value of -2. But the negative comes into play with the direction. All right. So keep that in mind. Our midline would be where? 3. So that means I'm going 2 away from that midline. So my max will be where? If I go 2 away from 3, up. 5. Min, if I go 2 away from 3, down. So I subtract 2 from 3. It'd be 1. So if I draw my max, my mid, and my min, all right, my mid would be at 3. So right here. My max will be at 5. So here. And my min will be at 1. So right here. So there's my max and my min. All right, don't be confused with the max and the min of the previous graph because it's on the same graph, which kind of sucks, but it's okay. So remember, you always want to start at the y-axis. All right, now this is where that negative comes into play. So remember, cosine is either going to start at the max or the min depending on if the a value is positive or negative. So if the a value is negative, is it going to start at the max or the minimum? The minimum. So we're going to start at the minimum, and then where are we going to go next? The mid, then max, then mid, then the min. And if we go backwards, we go mid, max, mid, min. So the graph should look something like this. So this is my -2 cosine of x plus 3. So what's the range of that graph? 1 to 5. So does everyone understand the graphing aspect using the max, the mid, and the min? We're going to do some more practice of this, all right, in just a minute. I'm going to shift gears, all right? But so the range, essentially, how did we find the range of the trigonometric functions? Can anyone explain that to me? It's the max and the min, and how do we find the max and the min? We take the midline and do what? Add or subtract the amplitude. Good. So to find the range, you have to find the max and min. And to do that, you take the midline and add or subtract the amplitude. So without actually graphing these, we can find the max and the min of these two graphs. So what's my midline to start? My midline is at y is equal to 4. What's my amplitude? My amplitude is at 7. So that means for my max, I'm going to add 7 to 4. And for my min, I'm going to subtract 7 from 4. So what's my max? What's 4 plus 7, guys? What's 4 minus 7? -3. So my range is from what? -3 to 11. Try letter B and C on your own. So find the range of letters B and C. So guys, heads up. Come on, my sleepy babies. All right, guys. So, what did you get for the range of letter B? -3.7. Good. So, my midline was 2, so that means I would be, and it didn't matter if you used the -5 or +5, it would have worked either way. All right. So, let's say you did the negative. You would have to subtract -5 and then add -5. So, that would have been 7. That would have been -3. If you did it with the +5, it would have given you the exact same results. Yes, ma'am. Emery's next, you can go. What about for letter C? All right, so it should have been 10 and 60. So if 35 was the midline, so if you add 25, you should have gotten 60. If you subtracted 25, you should have gotten 10. So it's been from 10 to 60. Now, this next one, they told us that we have a sine graph, and it looks like this. And they want us to determine the values of A and C. All right. And they were nice enough to give us our max and our min points. So our max is at what value? My max would be at what value? Y equals 22. Where's my min at? It's at 6. So my min is at y equals 6. So let's start by finding my midline. Now, if your max and your min is the same distance from your midline, what would be the best strategy to find it? Subtract what? Subtract 22 and 6, and then do what? So if I subtract 22 and 6, that will tell me how much space is between here and here, but that won't give me the midline. And then we would divide it by 2. So I'm going to subtract 22 minus 6, and that'll give me what? It would be 16. So this space is 16. So how far away should the midline be? 8 away. So if I divide that by 2, my midline should be 8 units away. So since it has to be 8 units away on both ends, that means that 8 is considered my what? 8's not my midline, but it is my what? It's my amplitude, because that's the distance away from the midline. So my A value is equal to 8, because that's my amplitude. Now, how do I figure out where the midline is? You can either add 8 to 6 or subtract 8 from 22. Either way, it will give you the same number. So I suggest doing both to check that you did correctly. So if I do 22 minus 8 and 6 plus 8, what do I get for both? 14. So my midline should be right here at y equals 14. So that means my C value is 14. So if I rewrite in terms of sine of x, I have y is equal to, what comes first? So we're plugging the A, yeah, so we're plugging the two numbers back in for the variables into this function. So it would be 8 sine of x plus what? 14. All right, so we're going to shift gears a little bit because I want us to do a little bit more practice with this before we move on to the last key feature, which is period. So what I want you guys to do is keep your packet out because we will come back to it, but take out your Chromebook and get on to Delta Math. Tobias, can you just let Gabby overlook yours? So the one that I want you guys to go to is the one labeled 8.4 trig graph features.
So Gabby, the bias is gonna let you look on his, so just follow along, okay?
It's somewhere. Last time I saw it was over there somewhere. All right, so you're going to 8.4 trig graph features. We're going to do a couple of these problems together. Because these are pretty, Delta Math does a pretty good job of breaking down how to find each of the different key features. All right. So, I want you guys, when you get into it, click on the very first single problem. So the one that says midline from a trig graph single. That's something for my math 2 class. We're doing probability steps. So get on Delta Math, go to the very first problem. All right. Is everyone on this Delta Math? Yes, no, maybe. All right. So this problem wants us to determine the equation for the midline. So our answer will be y is equal to some number. All right. So this is a little bit more visual than what we were doing. All right. They already gave us the graph. So remember, the easiest way to do it is to find your max and min first. So what is my max? Let's go. Addison. What's my max? 3. So 3 is my max. So it's right here. So my max is at y equals 3. All right, where's my min? Let's go. Jacob.
I'd say -1 or -2.
Well, what's my minimum? So what's my lowest?
Or at least a bit.
Sorry, -5. Yeah. Sorry, min with an N. So my min is right here. So, easiest way to find the exact midline without kind of guesstimating is you want to figure out the distance from here to here. So we don't necessarily have to subtract, but let's just count it. So how many units are from -5 to 3 if you count them? So take a minute and count them on your screen because it's probably hard to see on my screen.
Yes, go.
So how far away is it? It's 8 units. Now we can double check by doing 3 minus -5, and that's 8. So that means our amplitude has to be what? 4. So that means I want to be 4 units away from -5, 4 units away from 3. So what's 4 units away from -5? -1. All right. What's 4 units away from 3? -1. So we're talking about within this space. So you can't go past 3 and you can't go past -5. So in other words, you would take the 3 and you subtract the 4. You take the -5 and you add the 4. So this would be -1. This would be -1. So you have the exact same number. So, yep. So it's 4 here and 4 here. So our midline is at y equals -1. Does everyone see how to find that? So it's literally the same distance. So you just have to find how many units from the max to the min, half it, and then go that distance away from either one of them to get your midline. So you will literally type in y equals, make sure you hit the y equals. They are finicky about that. Y equals -1. So if we submit the answer, it is correct. Any questions on finding the midline? All right. So go to the first one that says finding amplitude. So these are the two that we know how to do. We know how to do midline. We know how to do amplitude now. So go to the one that says finding amplitude, the very first one. So basically, to find the amplitude, because they don't already have the midline marked, all right, finding the amplitude is pretty much the same thing as finding the midline, except you don't have to do the last step, which is count, how many units you just found for the amplitude to get the midline. All right, so I'll be my first step here. First off, what's my max? Let's go. Braden, what's my max? 5. So 5 is my max. What's my min? Let's go Socorro. -1. Good. So take a minute, figure out how far away the max and the min are from each other, but don't say it out loud. So figure out how far away the max is from the min, but don't say it out loud. It would be 3. What part of don't say it out loud? So how far away is the max from the min? Don't say it out loud yet. Just think it in your brain. So you can either count it or you can subtract the 2, either way. All right, so how far away is the max from the min? Let's go, Nathan. 6 units, good. So you could have counted it, or you could have done 5 minus -1. This becomes positive, so that's 6. Yes. So if the max and the min are 6 units apart, and the midline is halfway between that, what will be your amplitude? 3. So if you cut the 6 in half, your amplitude is how far away your max and your min are from the midline. So that would be 3. So my amplitude, you just divide 6 by 2, your amplitude would be 3. Now, just for funsies, what would the midline be? Anyone?
3. No, 2.
If you had 2. 5 minus 3 is 2. Negative 1 plus 3 is 2. So the midline would be at y equals 2. So for this one, you're going to put 3.
What was that again?
Tree.
3.
Yeah.
Amplitude from a tree.
All right. So you should have put 3. It should have been correct. All right. Now, the last one is period. So before we go to the... Okay, yeah, it's not the type of period that you think it is.
Brother man.
Take your head out the gutter. All right. So, all right. So I think it's a little easier to see from a graph first before we actually learn how to graph it. All right. So let's do that last single problem. So click on the one that says period, the very first one. Shut up, y'all. Oh, it's nothing bad, but some are giggling. All right, so we briefly talked about this yesterday when we did the basic graphs. So remember, a period is the horizontal distance that it takes for the graph to complete one cycle. Oh, Lord. Okay, so basically, if you want to go with the women's menstrual cycle, that's one way you can remember it. A period is one cycle. Like, literally, that is what it is. Like, literally, in math, it's one cycle of the graph. All right? So, that's one way to remember it. All right, so guys, how you figure it out is, first off, basically, you need to figure out what the pattern is. So I always start at the y-axis. So when we're hitting the y-axis, does it look like it's going to be hitting the midline, the max, or the min at the y-axis? The midline. So that means that when we go one cycle, it should end at the midline again. All right? And by one cycle, I mean we've gone up, and we've gone down, and we've gone back. All right? So one cycle means you've gone both up and down. All right? So let's just follow the graph. So it goes up, back to the midline, down, back to the midline. Now, do you think that's one cycle?
Yes.
Yes, because what's going to happen next? It's going to repeat. All right? So that's exactly what it would do. Go up, mid, down, mid. Now, if it was cosine, because this is clearly a sine graph because it starts in the middle. All right, if it was cosine, if it started at the max, it will end at the max. So in other words, you'll go all the way down and all the way back up. If it was min, you would start all the way at the bottom, go up, go all the way down. Yes. Yes, it would be 2 pi over 3. What? Jason, you can go after him. I guess that's a question.
Yes.
So basically, your period, the easiest way to find it is whatever the distance is from the y-axis and the x value that it lands on when it ends. So when one cycle ends. So it's basically this distance from here to here. Now, it's very nice because since this is 0, if we subtracted it to find the distance, we would just get whatever this value is. So our period would be what?
2
2 pi over 3. That's the x value where it ends.
Is that the answer?
Yep, 2 pi over 3.
Yes.
Jason,
Right.
I'm sorry.
So you should get 2 pi over 3.
You're blind.
One, two, three. Oh no!
Oh no! Oh no! Oh no!
Oh no!
I would never do. I only have friends. I'll do it to you.
What are you doing?
What? I'm just
What are you doing?
Oh no. What fell apart? And that.
Are we getting a bigger reaction?
No.
You say no.
Yeah, I said no.
Oh.
All right. So you should have put 2 pi over 3. Now, we're going to pivot back to our packet and actually show how to do it graphing wise. All right. So go ahead and close your Chromebook for right now. We'll come back to it in a minute. And go back to your packet. 2 pi over 3. Good. All right, so all right, so I'm on page 25. So page 25 of your graph. All right, so yes. All right, so basically, so again, the period is the horizontal distance or the horizontal stretch or compress from the sinusoidal graph. So it's just the horizontal distance for it to take to complete one cycle. All right. Now, for most periodic functions, they do not have a period of 2 pi. So the kind of so basically the default period is 2 pi. So all the ones that we've done so far, their periods were 2 pi. So both of these were 2 pi. These were 2 pi because one cycle took 2 pi units. All right. So now we're going to look at some where the periods are not 2 pi. So if our default is 2 pi, that means this is based off of our b value. So we're looking at y is equal to a cosine of bx plus c, or y is equal to a sine of bx plus c, where b is what we call our frequency, but it's where our period comes from. So if my default is 2 pi, that means when my b value is equal to 1, my period is equal to 2 pi. So how do you find your period or your b value? It's basically the same thing. So to get your period, and guys, I know what I'm saying. Shut up. All right, so for period, all right, our period is, if our b value is 1, that means that I took 2 pi and I divided b to it. Because if you divide 2 pi by 1, what do you get? 2 pi. Now on the opposite end, your b value is you take 2 pi and you divide it by your p, or your period. Because what's 2 pi divided by 2 pi? 1. All right. So these are your formulas. So the b value is what goes in the function. Your p value is for the graph. All right. So here's my question to you. So, hush. Yes. All right. So, they graphed this graph here. So y equals 3 cosine of x. So my b value is what? Here. My b value is equal to what? It's equal to, not my p, my b. No. My b value, guys, what's the number in front of this x? 1. The highlighted one. So if b is 1, that means the horizontal distance of this graph. Hush. So now if we look at the graph to get the period, if we start at the y-axis, all right, we start at the max. That means we're going to end at the max. So we go to the mid, min, mid, and max. So where do we end? How far was one cycle? 2 pi. So our period is 2 pi. Now, they then want us to find y3 cosine of 2x. So any predictions on how long you think one period is going to be?
3 spaces.
So how long do you think it's going to be to complete one cycle now?
4.
5, yeah, 4, 5.
4, 5, 4, 5.
I'll make you down to the 5.
So what's my b value? My b value is 2 now. So if I put it into my period formula, so period is equal to 2 pi over 2. So what happens to the two 2's? They cancel out. So that means my period will be what? Pi. So I'm going to complete one cycle by the time I hit pi. All right. Now, here's how you find what I call your reference points. So what did they do right here? So there are how many reference points between 0 and 2 pi? 5. So there are 1, 2, 3. It's divided into fourths. All right. So essentially what you do is you take whatever your period is and divide by 4. So if you take your period and divide it by 4, that gives you the increments that you should be increasing in. So those are your, in other words, those are your checkpoints. So if I divide pi by 4, what are my new increments going to be? pi over 4. So in other words, I'm adding a pi over 4 every time. So from 0, my next increment would be pi over 4. Then, if I add another pi over 4, what do I have? Pi over 2 or 2 pi over 4. If I add another pi over 4, what do I have? We already had 2 pi over 4. That's pi over 2. Then 3 pi over 4. Then 4 pi over 4 pi. Then 5 pi over 4. 3 pi over 2 or 6 pi over 4. 7 pi over 4. And then 2 pi is 8 pi over 4. And we're going to do the same thing going backwards. This will be negative pi over 4. Negative 3 pi over 4. Negative 5 pi over 4. Negative 7 pi over 4. So, I now need my midline, my max, and my min, so I know where I'm hitting. So where's my midline? What's my C value? 0. There's nothing there, so it's 0. So my midline's at 0. What's my max? 3, so right here. What's my min? Negative 3. So it's a cosine graph. So on the y-axis, am I starting at the top? So the max, the mid, or the min? The max. So I'm going to start here. Then my first checkpoint is going to be at the mid at pi over 4. So here. Guys, stop giggling. You sound like a bunch of gossiping old biddies. Quit giggling. All right, so then once I hit the mid, where's my next point? The min, and it's at pi over 2. Then I hit the mid again at 3 pi over 4, and then I finish my cycle at pi. So right there is one cycle, and then I'm just going to repeat the process till I run out of graph. So mid, min, mid, max. Then for the negatives, I'm just going to go backwards. So mid, min, mid, max. Oh, I totally did that wrong. No, did I? No, I'm right. Mid, min, mid, max. So my graph is going to look like this. Now, if originally one cycle was 2 pi radians and our new cycle was pi radians, from 0 to 2 pi, how many cycles did I complete for the red graph?
30. It's 30. It's actually 1, 2, 3, 4, 1, 7. I mean,
So, from here to here, how many cycles did I complete?
1, 2.
2. So here's one cycle. That's one cycle. And here's the second. Does that make sense in terms of what our frequency was?
yeah. Oh. With social degrees. That's how much.
So if your B value is that number, that's how many cycles you should have between 0 and 2 pi.
That's kind of crazy.
All right. Now, this also lets you find your period by, that's why we divide it by into 2 pi, so we know what the period is. Does that make sense?
That's so smart.
All right. So So we should have 2 cycles. All right. Now, we're not going to graph the same graph, but because I don't want the graph to get too busy because it will get really busy. All right. But at the same time, let's at least calculate the period and the all right, and figure out how many cycles there will be. So first off, based off of your B value, which is right here, how many cycles do you think are going to happen between 0 and 2 pi? Half a cycle. So half a cycle within 2 pi radians. Now, so that means that my period is going to be, P is going to be equal to 2 pi divided by 1/2. Now, if I'm dividing a fraction, that means I'm doing what? Multiplying by its reciprocal. So this is the same thing as 2 pi over, guys, stop talking, times 2 over 1. So this will be 4 pi over 1. So my period is 4 pi. So that's why we only do half a cycle in 2 pi radians, because it takes 4 pi radians to go 1 full cycle. All right. Does all this make sense, guys? All right. So just to recap, when B value was 1, the period was 2 pi. When it was 2, the period was pi. And when it was a half, the period was 4 pi. All right. So again, the relationship. So B is equal to 2 pi over P, and P is equal to 2 pi over B. They're essentially the same formula. You just alternate the P and the B depending on what you're trying to find. All right, so let's try graphing this function together. All right, so now that we know everything, we're now going to list everything. So I'm going to start by listing out my A, B, and C values. So what's my A value? 2. What's B? What's C? 0. So now I'm going to list out the key features. So my amplitude is what? My amplitude is 2, because you take the absolute value of it, it's 2. My midline would be where? Nope. 0. So y equals 0. Comes from your C value. So that means my max, if my amplitude's 2 and my midline is 0, where's my max? So it's 2 higher than 0, so it would be 2. So you do 0 plus 2, so it'd be at 2. My min would be where? -2. You subtract 2 from 0, -2. Now, my period. I'm going to take 2 pi and divide it by what? 4. So that is what? Pi over 2. So 1 period is going to take me pi over 2. So that's where 1 cycle ends. So in other words, if we went all the way to 2 pi, it would take how many cycles? So if 1 cycle is ends at pi over 2, how many cycles would it take for 2 pi? 4. Good. Now, last thing I need is my increments of my x's. So I got to divide pi over 2 by 4, because remember, we want 4 increments. So if I divide pi over 2 by 4, that's the same thing as multiplying by what? What's the reciprocal of 4? 1 over 4. So this is the same thing as pi over 2 times 1/4. So that'll be pi over 8. So I'm going up in increments of pi over 8. So we're just going to do our graph in terms of one cycle on each side of the x-axis. So this would be pi over 8. And we're ending at pi over 2. So what would be my next value? Nope. So I'm adding pi over 8 each time. So guys, if I add a pi over 8, what's 1/8 plus 1/8? 2 over 8. So this will be 2 pi over 8, which simplifies down to pi over 4. Add another 1/8. What do I get? So if I add another 1/8, what's 2/8 plus 1/8? 3/8. So 3 pi over 8. And then we end at 4 pi over 8, which is pi over 2. And then backwards, you just do the negatives of them. So that's how you typically start a graphing. Now, then I'm going to label my midline and my max and min. So my max is here. Mid is here. And min is here. So remember, I draw these lines because those are my checkpoints. So on the y-axis, this is a sine graph. So if it's a sine, which line is it going to hit on the y-axis if it's a sine graph? It's going to hit the midline. Now, since my a value is positive, am I going to go to the max first or to the min first? The max. So at my next checkpoint, or pi over 8, I'm going to hit the max. Where I go next? Mid, then the min, yes. And then back at the min, or the mid, sorry. So that's one cycle. For the negatives, you just go backwards. So min, mid, max, min. And this will be my graph. Now remember, even though it looks like just a standard sine function, remember, this is actually smaller than what it would appear if we graphed it on something that was labeled with 2 pi. Because remember, 4 cycles would have to happen before we hit 2 pi. So 4 more of these would have to happen before we get 2 pi. All right, does everyone understand that? Does everyone understand kind of the basics of how you graph the sine and cosine functions? All right, and we'll do a little bit more practice with this tomorrow. All right, so what I need you guys to do is we're going to do your next unit circle quiz. So clear your desk of everything except for something to write with. I'm going to put